So very good day to everybody. This is wireless networks, and in today's class we'll discuss about the Wi-Fi technology, which is nothing but IEEE 802.11 standard. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So in this class, we'll have a short introduction towards Wi-Fi, the variants of Wi-Fi, how Wi-Fi standards have evolved, the IEEE 802.11 1997 standard, 802.11b standard, 11a standard, okay. Then we'll understand 802.11a modulation rates and of course the data rates for the 20 megahertz channel spacing. So then we'll discuss about 802.11g standard, 11n standard, 11ac standard, okay, and we'll try to compare OFDM, orthogonal frequency division multiplexing, with the orthogonal frequency division multiple access resource allocation. So finally we are going to end this class with the PLCP, protocol data unit, PPDU, okay. So at regular intervals I'll be giving you some short videos to discuss the knowledge in our topics, right? Wi-Fi, you know everything, okay. So Wi-Fi is a major form of communication for many of the devices, even with the home automation, increasing day by day. So several devices also you are connecting. For example, using one Wi-Fi you can connect up to 8 devices, something like that you can have, okay. So home Wi-Fi is a very large area of usage of technology, with most homes that use broadband connection to the internet using the Wi-Fi access as the best means of communication. So LANs, local area network of all forms, will be using Wi-Fi as the main form of the communication along with the Ethernet cable, okay. So maybe for the homes, office, several of the areas you will use Wi-Fi as a major carrier of data. So you take in the case of LAN, local area network, it can be wired or maybe wireless or maybe both wired and wireless in the most of the cases. So maybe to enable different items incorporating the wireless technology to communicate with each other, so you should have some common standards, okay. So for that only we'll go for IEEE standard, okay. So the standard for Wi-Fi is IEEE 802.11 standard, okay. So there are several variants like 802.11n or maybe 802.11ac. So we'll have different upgrades with the overall series, and we have different variants. So by releasing the updated variants, the overall wireless LAN technology has been able to keep pace with the ever-growing requirements for the more data and of course high speed even, okay. So we'll have 802.11b 11 Mbps, 802.11a 54 Mbps, 802.11g 54, 802.11n, it is Wi-Fi 4 600 Mbps, okay. 802.11ac Wi-Fi 5 6.8 Gbps, okay. Then 802.11ax Wi-Fi 6, okay, it is having 10 Gbps. So more data, higher speeds, okay. So since Wi-Fi has been released to consumers back during 1997, the standards have been continuously evolving. So we'll have faster speeds, network is broad, spectrum is broad, and efficiency is also very high for the users, okay. So as capabilities were added to the original 802.11 standards, okay, so we'll have like 802.11b, 11g and so on, okay. So we'll have different standards, year of release, frequency bands, bandwidth, maximum theoretical data rates achieved also. So typical data rates are lower than the theoretical ones based on several factors, maybe based on the distance, based on the modulation rate, based on FEC, forward error correction coding, bandwidth usage, MIMO, multiple input multiple output multiplier, guard interval, and of course error rate, it will be different, okay. So this 802.11 family consists of a series of half duplex over the air modulation techniques that will be using the same basic protocol for the wireless communication. Okay, so we'll see the comparison table. Okay, so IEEE 802.11, it is 1997. So the release year is this 1997. Frequency band 2.4, bandwidth 22, 2 Mbps speed. That's all. So 1111B again 1999, same thing. 1111A 54 Mbps, 1111G 2003 54 Mbps, 11N, okay, so Wi-Fi 4 2009, it is 2.4/5, bandwidth 20 to 40, 600 Mbps. Okay, so then 11AC 2013. Okay, so 20, 40, 80, 160. So here you will be having 6.8 Gbps. Then 1111AX introduced during 2019. So same 20, 40, 80, 160, 9.6 Gbps. 1111AX. Okay, so Wi-Fi 6E. Okay, back 2020 only. Okay, so 9.6 Gbps. 11BE Wi-Fi 7. Okay, next year. Ikramatur. Okay, so we have 46.1 Gbps. See here, 9.6 Gbps, 46.1 Gbps. So that much speed. Okay, that much speed, we are going to enjoy the data rate. Okay, so as you know, 802.11 1997. Okay, Birming Tokusius Tokson Yetta. So that was the first wireless standard in the family released in the 1997. So this standard defined the protocol and of course the compatible interconnection of data communication equipment in the LAN, local area network, using the carrier sense multiple access CSMA collision avoidance. Okay, so CSMA CA is a network access method in which the channel's idleness is actually checked before the beginning the data transmission. So this standard supported 3 physical layer technologies. We'll have IR, infrared, that is operating at 1 Mbps. Then we have FHSS, frequency hop spread spectrum, that is 1 Mbps, and an optional 2 Mbps data rate, or maybe DSSS, direct sequence spread spectrum, supporting both 1 Mbps as well as 2 Mbps data rate. Okay, so the protocol was not widely accepted because of the interoperability issues, cost, and of course insufficient throughput. So then we'll have IEEE 802.11b standard. So here you see the products appeared in the market during 1999. Okay, so they had maximum theoretical data rate of 11 Mbps and it will be using CSMA, carrier sense multiple access collision avoidance medium access method. So here the dramatic increase in the throughput of the 802.11b along with the price reduction led to the wide acceptance of 802.11b as the wireless LAN, local area network technology. So 802.11b used the ISM, International System for Mobile Unlicensed Frequency Band, from 2.4 to 2.5 GHz. Okay, so here you see infrastructure mode, ad hoc mode. Ad hoc mode means peer-to-peer, end-to-end. Okay, so here wired LAN distribution system will have the AP, access point, wireless stations are there, base station subsystem. Then you have wired LAN distribution system, access points, everything wireless. Okay, so here you have extended service set. Okay, then you will have server communication through the wireless station. Okay, so independent base station subset. Okay, so this is the independent case with the ad hoc or maybe end-to-end or maybe peer-to-peer networks. So the protocol was a direct extension to the direct sequence spread spectrum and used CCK, complementary code keying technique, as the modulation technique. Okay, so 802.11b was a multi-point, like point to multi-point configuration where the access point communicates with the mobile clients within the range of the access point. So this range depends on the RF environment, radio frequency environment, output power, and of course the sensitivity of the receiver. So 802.11b had a channel bandwidth of 22 MHz and operated at 11 Mbps, but could have scaled back to 5.5 Mbps. Then to 2 Mbps and of course 1 Mbps adaptive rate selection in order to decrease the rate of the rebroadcast that result from the errors. So this 802.11b standard shared the same frequency bandwidth as that of the other wireless standards. So within the home, wireless devices maybe like microwave oven, Bluetooth devices, cordless phones cause interference with the Wi-Fi, resulting in the data transfer rate taking a hit. Within the home, the wireless devices maybe like microwave ovens, Bluetooth devices, even the cordless phones even cause the interference with the Wi-Fi that results in data transfer rates taking a hit even. Okay, so then we'll move on to 802.11a standard. So 802.11a standard use the same core protocol as like the original standard. However, it is operated at a frequency of 5 GHz. So that it used the 52 subcarrier OFDM, orthogonal frequency division multiplexing, and maybe it had a theoretical data rate of 54 Mbps. So maybe in the practical scenario, the Wi-Fi achieved a throughput of mid 20 Mbps. Other data rates were 6 Mbps, 9 Mbps, 12 Mbps, 18 Mbps, 24, 36 and 48 Mbps. Okay. So even though both the protocols are released in the same year, okay, 802.11a and 11b, 11a was not interoperable with 11b as they operated in different unlicensed ISM frequency bands. So the 5 GHz band gave 802.11a an advantage in terms of data transfer rate, since the 2.4 GHz was getting crowded due to the occupation of the spectrums by other devices. But operating at a frequency also reduced the operating range of the devices which use this 802.11a standard. So the solution was to go for more powerful antennas which had the potential to boost the range by a bit. However, their use was largely limited to the routers deployed in the large organizations based on the requirement of the powerful antennas and of course the higher price. Okay. So out of all the 52 OFDM subcarriers, 48 were dedicated for data and 4 were pilot subcarriers with a carrier separation of 312.5 kilohertz. Okay. So each of these subcarriers would be BPSK, binary phase shift keying, QPSK, quadrature phase shift keying, 16 quadrature amplitude modulation QAM, or maybe 64-bit QAM. So the bandwidth of the channel was 20 megahertz with an occupied bandwidth of 16.6 megahertz. Symbol duration 4 microsecond, that includes a guard interval of 0.8 microsecond. So OFDM will have like reduced multipath effects in the reception, and of course will have increased spectral efficiency. So we are going to compare the 802.11a modulation rates and the data rates, especially for the 20 MHz channel spacing. So modulation type is BPSK 1/2, data rate 6 Mbps. Then BPSK 3/4, 9 Mbps. Quadrature phase shift keying 1/2, 12 Mbps. And QPSK for a coding rate of 3/4, it is 18 Mbps. Then similarly 16 QAM 24 Mbps, 16 QAM again 36, 64 we have 48, 64 we have 54. Okay, so we'll have difference. Then we have 802.11g standard. So that became available during 2003. So it used the same OFDM technology introduced with the 802.11a standard. So 802.11g combined the best of both 802.11b and 11a in order to make users interested in investing in a device supporting the wireless communication protocol. So Wi-Fi standard supported a maximum data transfer rate of 54 Mbps like the 802.11b while working at 5 GHz frequency in order to offer a very higher range like the 802.11a standard. Okay. So IEEE 802.11g protocol was backward compatible with the 802.11b. Okay, that's an advantage. So 802.11b devices could connect to the 802.11g access point, limited by the capabilities of the device supporting the older protocol. So both advantages are there, disadvantages are also there. Okay. So 802.11g was able to handle dual band or maybe dual mode access points using 802.11a and 802.11b/g. Okay. So then we'll have 802.11n standard. So maybe if the 802.11g was the first Wi-Fi standard, good enough for the commercial use, 802.11n was when things started to get better. Okay. So with 802.11n, Wi-Fi even became more faster, even became more reliable. Okay. So you can achieve it using MIMO, multiple input, multiple output, and maybe 40 megahertz channels to the physical layer, and of course frame aggregation to the MAC layer, media access control layer. So MIMO is a method especially for multiplying the capacity of the radio link using the multiple transmit and receive antennas in order to exploit multipath propagation. So these antennas has to be spatially separated so that the signal from each of the transmit antenna to the receive antenna has a different spatial signature, so that the receiver can separate these streams into parallel independent channels. So channels operating with a bandwidth of 40 MHz double the channel width and provide twice the physical data rate over a single 20 MHz channel used in the previous generation of the Wi-Fi. So 802.11n draft allowed up to 4 spatial streams with a maximum theoretical throughput of 600 Mbps. Okay. So 20 MHz channel will have 56 OFDM subcarriers. Okay, so we'll have 52 for data, 4 for pilot tones. So there we have a carrier separation of 312.5 kilohertz. Okay, so this 802.11n supports frame aggregation where the multiple MAC service data unit MSDU or maybe MAC protocol data unit MPDU are packed together to reduce the overhead and average them across multiple frames, thereby increasing the user level data rate. So you can say that 802.11n standard is backward compatible with 802.11g, 11b and 11a standard. So this 802.11ac, the farther end. Okay, so AC revised up the Wi-Fi standard by providing GBps, gigabits per second, and that has been achieved by extending the 802.11n concepts, which include wider bandwidth, maybe like 160 MHz, more multiple input, multiple output spatial streams up to 8, downlink multi-user MIMO up to 4 clients, and high density modulation 256 QAM. So that is the advantage. It supports 256 QAM at 3/4, 5/6 coding rate with the requirement of 6 dB tougher system level EVM requirements as well. Okay, so 11AC, of course, it is available in the 5 GHz band. So dual band access point, of course, client still continued to use 802.11n standard at 2.4 GHz. Okay, so the first wave of this 802.11ac compatible devices was during incoming Un-Uch. Okay, so that supported 80 MHz channel and up to 3 spatial streams, which delivers up to 1300 megabits per second at the physical layer. Then we have the second wave of products, 802.11ac wave 2 products. So that was released during incoming Un-Bish. Okay, so we had more channel bonding, more spatial streams, MIMO, multiple input, multiple output, more multi-user. Okay, a significant advancement of the 802.11ac. Okay, so while MIMO directed multiple streams to single user, MU, multiple user MIMO, can direct the spatial streams to multiple clients simultaneously. So that improves the network efficiency. So 802.11ac uses a technology called as beam forming. Okay, so with beam forming, the antenna transmits the radio signals in such a way that they are directed at a specific device rather than having the signals spread in all of the directions. So when you do it properly, it causes a constructive interference that results in the strengthening of the signals in a particular region where the Wi-Fi client is present. Okay, so 802.11 AC routers are backward compatible with the 11B standard, 11G standard, 11A standard and 11N standard, which means that all of the legacy clients just works fine with the 802.11 AC routers. So we have the OFDM versus the OFDMA resource allocation. So here we'll have channel subcarriers, WLAN, wireless LAN packet. Okay, so we'll have the channel width. Okay, so this is OFDM. So here you see user 0. Okay, this is user 0, user 1, okay, user 2, and we have user 3. Okay, so this is the resource unit you will see for each of the users. Okay, orthogonal frequency division multiple access. Wi-Fi 6 802.11 AX. So it's called as Wi-Fi 6. It's a 6th generation of Wi-Fi built on the strength, the advantages of the 802.11 AC, which provides more wireless capacity and more reliability. So 11AX achieves the benefits by using denser modulation schemes, which means at 1024 QAM and orthogonal frequency division multiple access, reduced subcarrier spacing, okay, 78.125 kilohertz, and schedule based on the schedule you will be having the resource allocation. So unlike the previous types 802.11 AC, this 802.11 AX, it's a dual band technology that works in 2.4 as well as 5 GHz frequencies. So we'll have an upgrade in terms of speed even for the lower frequency band. So 11 AX is designed for the maximum compatibility that coexisting efficiently with the 802.11A, G, N and AC clients. Okay, so that is the advantage. So 802.11 AX uses OFDMA, orthogonal frequency division multiple access, which allows RU, resource unit, that is going to divide the bandwidth according to the needs of the client. For example, you want more means we will allocate more. You want less means I will allocate very less. Okay. So also provides the multiple individuals with the same user experience and at the same faster speed. Okay. So with the 11 AC, of course, the Wi-Fi channel was broken down into the collection of smaller orthogonal frequency division multiple sub channels as well. Okay. So orthogonal frequency division sub channels as well. So at any given point in the carriers, in each of the PLC protocol data unit, we will be having all these groups. So with the orthogonal frequency division multiple access like 802.11 AX, individual groups of the subcarriers are individually allocated to the clients as the resource unit on the per PPDU unit. Okay, PLCP protocol data unit. So this is the comparison. The last two, Wi-Fi 5, Wi-Fi 6, we are going to compare. So bands 5 GHz, here 2.4 and 5 GHz. Channel bandwidth 20, 40, 80, 160, same. FFT, fast Fourier transform series, same. 64, 128, 256, 512. Here you see 256, 512, 1024, 2048, higher. Okay. Subcarrier spacing 312.5 kilohertz, but with the AX standard very less, 78.125 kilohertz. Symbol duration 3.2 microsecond plus 0.8 or 0.4 microsecond. So here 12.8 microsecond plus 0.8 or 1.6 or 3.2 microsecond. Highest modulation 256, here 1024. Maximum data rate 6933 Mbps, here 9607.8 Mbps. Okay. So even like 2024, even 96 Gbps we are going to enjoy. We are just waiting.